So now the topic is about vector subtraction. And just as always, we take two vectors to start with in our example. So a vector A as usual and a usual vector B. Okay, vector B. Let me just increase the smoothness. Okay, now it's good. Now, okay, this is the vector B right over here. Now we have to do the vector subtraction. So before vector subtraction, let's look at opposite vectors. So what are opposite vectors? So let's say a vector, it is going in this direction. Let's say it's going in this direction, and this is the vector A. Okay, and suppose another vector with the same magnitude of A, let's say it is x, this is also x, the length, it going in the opposite direction about 180 degrees apart. So 180 degrees apart, it is going in the opposite direction. Then we will call that vector the opposite vector of A, or vector minus A. That's the vector minus A. And we'll use this theory right over here. So just at the initial point, but 180 degrees apart from it, you just remember it's going to be 180 degrees apart, we will draw of the same magnitude. This is R, this will also be R, a negative of A vector. Okay, now we can do our vector subtraction. So what vector subtraction told us that we needed to have B minus A, but we can write that as B plus minus of A. We can write that, of course we can write that the plus and minus will eventually turn into this minus sign. So we can now just add this vector over here, the negative of A vector, and add it up to this B vector right over here. So just take the B vector, let's just take the B vector and project it right over here, and the thing will get right about here, from the initial of A to the end point of B. The straight line drawing sequence is very hard. Okay, this is the R vector, so this will be vector R. So just like this, when we are trying to define any vectors, let's say vector A minus vector B, now we'll just quantify, or we'll just denote that as vector A plus minus vector B. So we will always use the plus sign right here, and we will do our modifications to the next vector. Okay, we're doing our modification to the next vector. So if I were to say minus B, so what I would do in this figure is we will move 180 degree apart, right, 180 degree apart, and I just pull it straight up of the same length in the same direction. Now that is the negative B, and then you will have our A minus B. Now let's see, A minus B, does it give us R now? Does it give us R? Let's see. So this is our A right over here. This is our A vector, and this is our negative of B vector. Negative of B vector. Now what does this give us? Oh, sorry, that's not it. This will slightly be, not slightly, very, it must be there. Yes, this is our minus B vector. Now what will be the resultant? The resultant would be like this. So R. And let's see right over here, is this the same? Of course it's not the same. The R is completely opposite right now. The R is completely opposite to it right now. So we can clearly say that b minus a is not equal to a minus b. It doesn't follow the general formula, and it is also true in general formulas as well, most of the cases. Let's say we have 5 and 4. 5 minus 4 will give us 1, but 4 minus 5 will give us minus 1. So 5 minus 4 will not be equal to 4 minus 5. That's clearly it. And that is also true for this formula. So we can say in word that it does follow in quite a few examples. But I would clearly like to say it doesn't follow the cumulative formula for subtraction. And that's pretty much it about vector subtraction and vector addition. And in the next video, we'll clearly try to learn that if I have the magnitude, let's say this was 5 and this was 4, and this angle between them, that is very important, let's say 60 degrees, how could we find this r? How could we find the resultant and also the angle of the resultant? We'll find it out in the next video. Till then, stay tuned.